Hey Math 8 kiddos, let's go ahead and review our scatter plots and data, whether this is for the first time you're taking the test or if you're planning on taking a retake. I'm only going to focus on a few problems from the study guide, so if you have that in front of you, follow along with me. Let's take a look at problem number 4. We want to decide what type of association each of these scatter plots have. Let's start with using the words positive, negative, and none. Letter A is negative. You can see the dots on the scatter plot are going in a downward position. So as x is increasing, the y values are going down. B, it looks like someone threw sprinkles all over the floor. So that one is no correlation. Letter C, the dots are going in a positive or uphill direction. So that's positive. And then letter D, at first it looks like it's just moving horizontally, but then it does start to go upward. So we can call this one positive. Now we're going to look at each one and decide if they're linear or nonlinear. Remember, linear means it is a straight line. So letter A is linear. Since B is no correlation, it is nonlinear. C is going in a positive direction, that's linear. And D would be nonlinear because there's more of a curve to it. It almost looks like the letter J. Let's take a look at each of these questions. Number 5, which of the scatter plots could likely represent the number of food items ordered and the total number of calories consumed? So let's think about what's happening with each variable. As you order more foods, so as the number of food items you order increases, what happens to the calories that you consume? Well, that's also going to increase. So this is going to be a positive relationship. That is graph C. Now we're going to compare just plots A and C. Which one is a stronger correlation? So that's where we're looking for the dots to be closer together. That would be C. In 6B, which scatter plot has an outlier? That's where there's a point or two that's seen like they're off the main pattern. And if you look at graph A, we have an outlier right there that I circled for you. Let's move over to the next page. All right, problem number 14. So we're actually going to jump up to page 3 of the study guide. Here they're asking us to predict values. When you're asked to predict a value on a scatter plot, you want to start by drawing a trend line. So that's where you do your line of best fit so that it is about the average of all the points. Then we're going to approximate where it says what is y when x is 3. X is the horizontal axis. We'll go over to where x is 3. We'll see where that hits the trend line, and it looks like it's at y equals 150. All of our trend lines might be a little bit different, so all of our numbers might be slightly different, but it shouldn't be off by too much. Number 15 is asking us to predict x when y is 600. So what do we do first? That's right, you have to draw a trend line. Once your trend line is drawn, we can now go to where y equals 600. We're going to see where it hits the trend line that we drew, go down to what its matching x value is. It looks like I have in between 50 and 60, so I'm going to say that x is 55. You should have a number somewhat close to that. Number 16. Now we have a scatter plot and the trend line is already drawn for us. So we're going to write the equation of the trend line. We use slope-intercept form. That's y equals mx plus b. Let's start with the b value. That's the y-intercept. The y-axis is the vertical axis, and the trend line hits the y-axis at 40. So in y equals mx plus b, the b value is 40. Now we need to figure out slope. Slope is rise over run, so we'll start at the y-intercept, and we're going to look for other good points on our trend line, not the points that are plotted, but the trend line. It looks like we're going up 10 over 2. Up 10 over 2. Notice the y values are counting in increments of 10, which is why we're going up 10. And then each box along the x is increasing by 1, so that's why it's going over 2. So our slope is 10 over 2. We include our x variable and then simplify the equation. 10 over 2 is 5, so our trend line is y equals 5x plus 40. Then they want us to use our equation to predict the value of y when x is 15. So we could look at the graph, but there's no 15 on our x-axis. So we are going to use that equation. Y equals 5x plus 40. We replace x with 15. We're going to simplify that. So 5 times 15 is 75. Add 40, and we get 115. The next problem, we're going to use the equation to predict the value of x when y is 200. So we write our equation, y equals 5x plus 40. We replace y with 200. And we want to solve for x. We do that by subtracting 40 to both sides of the equal sign. So we get 160 equals 5x. Divide both sides by 5 to isolate the x, and we get 32. Let's take a look at the next problem. Several schools reported the number of students who received a flu vaccine in a year and the number of cases of the flu amongst their students that year. A scatterplot was made with a trend line that had an equation of y equals negative 1/4 x plus 85, where y is the total number of cases of the flu and x is the number of students who received a flu vaccine. Predict the number of cases of the flu that would occur if 300 students receive a flu vaccine. We need to make sure we use that equation that they gave us, and then we're going to substitute the number either in for x or y. So y equals negative 1/4 x plus 85. In the word problem, and I underlined it, x is the number of students. So that means 300 is going to be replaced for x. So y equals negative 1/4 times 300 plus 85. Go ahead and type that into your calculator. So negative 1/4 times 300 is negative 75. Add that to 85 and we get 10. So that means the number of cases of the flu that would occur is 10 cases. Number 18, predict how many students receive a flu vaccine if a school had 65 cases. Remember, the number of cases is the y value. So in the equation, y equals negative 1/4 x plus 85. We replace y with 65. And then we'll solve for x using inverse operations. We'll start by subtracting 85 to both sides. So we get negative 20 equals negative 1/4 x. Multiply both sides by negative 4. So x equals 80. So 80 students will need to get the vaccine. All right, let's move on to the last page with two-way tables. So in number 21, I started the table for you. And instead of looking at the rest of the data, we're just going to use addition and subtraction to finish filling in the table. So with this table, I want to look for a row or a column that has one empty box. I noticed that having a job in a car has an empty box in the car column. the number of jobs, people with a job and a job and no job would have to equal 9. So what plus 5 is 9? That's 4. I also notice that I can fill in the total row because I'm missing the 1 box. No car total. So I'm going to do 17 minus 9, and that's 8. Then I can fill in the rest of that column. This empty cell plus 5 has to equal 8. That would be 3. And now I can add straight across to finish filling in the total column. 4 plus 3 is 7. 5 plus 5 is 10. Now that this is filled in, we can answer the questions. Of the students surveyed, that's the denominator of your fraction. So we have 17 that have been surveyed. How many have a job? So of the 17, that means I'm focused on the total for the job, and that's 7. In your calculator, type in 7 divided by 17. Hit enter, and then multiply that by 100 to get your relative frequency. That's going to be a percent. That's 41%. Next, of the students who have a car, that's your denominator. So how many of them have a car? There's 9. Of those 9, how many have a job? That's 4. Divide 4 by 9, turn it into a percent, you get 44%. Last one, of the students who do not have a car, so no car is this column. There's 8 of them. How many have a job? That's 3. In your calculator, do 3 divided by 8. Multiply by 100, we get 37.5. 37.5 rounds up to 38%.